Okay, we are definitely going to need quality grade A here. I think you guys already know what we're here for, but for any of those who don't, we're building another 3D printer out of trash. Except this time, it doesn't even look like trash. And of course, we're starting out with the most challenging part, the wooden base. It's difficult because unlike most of the other parts for this printer, I can't just 3D print it, and woodworking in general isn't exactly known as the epitome of precision work. If you have a large enough laser cutter or CNC router, it's going to immensely simplify the job, but of course I don't, so we're doing it the old-fashioned way. I prepared a bunch of drawings here, one for each part. Not an enjoyable task, by the way, so let's get cracking. I already went ahead and cut the basic shape for the top panel and strips for the sides out of this 5mm HDF I'm going to use. This stuff in particular is really not a great material since it contains very little, if any, binder holding the fibers together, so the edges tend to fray rather easily. But on the flip side, it's very dense, and when you've got lots of it, it's extremely rigid compared to plywood or MDF. So the first thing I need to do here is transfer the hole locations. Again, if you have a laser cutter, you just chuck the whole panel on the machine and get them cut perfectly where they're supposed to go. But I'm going to use the rear edge of the panel and a center line, which I still have to draw, as my datums to reference all the other dimensions off of. Fortunately, it overall ended up unusually square for having been cut on the table saw, so I'm going to do my absolute best to get the center line as parallel to the edges as possible, so it'll also be perpendicular to the rear edge. By the way, if you have a square with a set screw like this, you can usually tune it to be almost perfectly square by drawing a line and then flipping it to see if it stays parallel to that line. If it doesn't, you adjust it slightly and try again. Takes a bit of trial and error, but usually you can get pretty darn close. Okay, I marked out the holes that don't have to be super accurate, which is not that many, as you may be able to see. Fortunately, these square ones here will be covered by printed parts later on anyway, so I can make them a millimeter larger than they're supposed to be to give myself some adjustability, which is just as well because I kinda have to cut them out on the scroll saw, which is easily one of the least accurate tools I have. That turned out about as accurate as ever, which is to say, not at all. Fortunately, it doesn't have to be perfect. I went ahead and cut the round holes out on it as well because they are only pass-throughs for the lead screws, and all of my 16mm drill bits, if you can call them that, are too dull to do even a half-decent job on this material without lots of tear out. Now for this last inaccurate hole, I'm running into a little bit of an issue where it's too far in the middle of the panel to be able to reach it with a drill press from any of the sides, so I have to resort to some truly barbaric measures and make do with the cordless drill. For everything else, I'm going to make heavy use of 3D printed drill guides because it's basically the only half reliable way I found to manually drill holes where they're supposed to go instead of within a 0.5mm radius. I printed these out on my wooden rep strap. Like I said, every single part for PrintoSapiens will be printed on it for better or for worse. These in particular did not turn out very great because my E-steps were totally out of whack, which I didn't notice until later, so they have oozing and over-extrusion issues all over. But I think with a little bit of careful cleanup, they can still be used and I don't have to reprint them. They are only single use anyway, so it would really be a waste. So this rear one goes right up against the edge of the board, and if you're wondering why I'm centering it from the sides instead of via the center line like I said, you're right, I'm not practicing what I preached here. The reasoning being that my center line is based on the sides anyway, and being a pencil line it has a width to it, which only exacerbates the fact that it's kind of blurry in the first place, making it difficult to find the exact center. And since the side edges are comparatively less blurry, I might as well use those. With the front drill guide, things get a little more difficult. Had I actually planned things through properly, I'd have made it a slightly different shape to make setup easier, but I didn't, so I have to jump through a couple extra hoops to get there. Moral of the story is, it's a drill guide for Christ's sake. It doesn't have to look pretty. Make it a shape that is convenient to use instead of putting unnecessary slopes and curves on it. Yeah. For the version you can download on GitHub, this will be fixed, so anyone wanting to replicate this printer has one less thing to worry about. Also, for drilling here, I'm not using the newest and sharpest drill bits I have, which may seem counterintuitive at first glance until you remember how on a brand new drill bit, the flutes themselves are still quite sharp, so it easily cuts sideways in soft materials like plastic. So what I'm using instead is a rather old brad point bit, which I sharpened at some point, so it has an easy time cutting into the material, but is actually quite reluctant to go sideways. In other words, the best of both worlds for this application. And it sucks that I have to go at it with a hand file here to clean up those elongated holes, but they are still covered by a printed part, so if you really want to, you can just drill them oversized instead. For the big one in the center, which is actually the one guiding the motor back and forth sort of straight as you adjust belt tension, I can just drill out the majority of the material with a 20mm Forstner bit, and then come in from underneath with my beloved palm router and a flush trim bit to copy the shape of the printed hole like a template. And this is about as far as I'll take it for the top panel for now. You might have noticed I haven't done anything about the iconic front bevel yet. That's because it's purely aesthetic and doesn't have to be accurate to within 1/10 of millimeters, so we can deal with it later, which is a lot easier anyway. Next step, let's prepare the sides and internal cross members. This should go without saying, but all these strips for the sides have been cut in one go without readjusting the table saw fence in between. While they don't have to be the exact width specified down to within 1/10 of a millimeter, they very much should all be identical in width, which is practically impossible if you move the fence in between. So rather cut a spare or two than later find out you don't have enough strips and have to try and match the width. To give you an idea of the accuracy I'm dealing with here, my strips are on average about 0.2 millimeters narrower in the middle than toward both ends. Not great, but should be plenty good enough here, and in my experience it's really hard to get much better than that on a table saw, at least on my wooden one here. The sides are fairly easy. I just trim one end for a good 90 degree and cut the other at 45. Oversized just so I remember which way they go. Then I have more scroll sawing to do. This is for the air intake and exhaust to cool the electronics. They really don't have to be accurate per se, but if they end up too crooked, it'll be ugly since the printed grills won't fit properly. And my reasoning for not using the bandsaw here too is that I need a cut with an acceptable surface finish, since it's almost impossible to reach that tight corner for any reasonable sanding. Again, a laser cutter would be the perfect tool to make these parts. Now, since the rear panel and the internal cross members are the exact same length, I'm just going to tape them together and cut them simultaneously. The rear panel also needs a rectangular hole for the power inlet, and you know what that means? More scroll saw! It's funny how that rarely ever used tool suddenly comes out of the woodwork and saves the day. Now, I realize there's a little issue here. The C14 power inlet I got is clearly designed for being put into a sheet metal panel, so these little clips here aren't going to latch onto my 5mm HDF. Now, I could just buy a different one instead, one of these with screw holes, but for one, those are too wide, so they actually physically would not fit on here, and secondly, they're essentially the exact same part, just clipped into another plastic piece to add the mounting holes. I can 3D print my own piece of plastic, even with mounting holes left and right instead of top and bottom to actually make it fit, but I don't want to. It's a very clunky solution. I want to make it fit the way it was designed to. And this involves, perhaps stupidly, machining the whole material thickness down to a single millimeter in some key areas for the clips to engage. Because the super thin material has zero chance of lasting otherwise, I'm soaking those recesses in super glue to strengthen it. I very much doubt this would survive being disassembled, but hey, I'm not building this printer to disassemble. Yeah, that's the modern throwaway culture mindset I designed this whole printer with, as will become increasingly obvious from here on. Basically because I already know in advance that by the time I need to fix something on it, I'll have become so sick of all the mistakes I made with this design that I'd rather build a whole new machine anyway than have to work around existing design flaws. But I guess that's just my personal excuse for an oversimplified, objectively probably bad design. Anyway, next I have the internal cross members to work on, and in spite of the central role they play in actually holding the entire printer together, they're surprisingly easy and straightforward to make. I just need to make them mirrored copies so the smooth sides of the material can face each other during assembly, which means for drilling, I'm actually going to put them smooth side out because I can't really accurately draw on this textured back. And for these bigger holes, since they're essentially nothing but pass-throughs for wiring later, it technically doesn't even matter where they go in the first place. I just put them in what seemed like the most convenient locations. The smaller holes, on the other hand, are indeed meant for screwing on the gantry, so they should be approximately where I specified. The accuracy I can get straight from the drill press will do just fine here, since the matching holes are going to be oversized for adjustability. Right, the last thing I need to do before I can move on to cutting some metal tubing for the gantry, which will be necessary for assembling the base, is cutting some additional holes for cooling air into the rear panel and left side, because my power supply probably wants a breath of fresh air too, and at the time of filming this, I have not yet added those holes in my CAD model. The thing is, while I have cooling vents left and right at the front, making the whole thing look like it has gills, which I guess sort of works, I do not want one in the back on the right because it'll just look weird, and I cannot think of a shape that wouldn't make it do that. So I do want to move that one to the back, so we have air being pulled in on the left and expelled out the back, allowing me to leave the right side untouched, because the right is definitely the pretty side of the printer, if that makes any sense, so I do want to try and keep it pristine. And because they are just rectangular holes, I can at least use the table saw this time. And I'm terribly sorry for the completely ruined footage here. The tripod was touching the saw, which it never should for the exact reason you can see right here. It transmits all the vibrations directly to the camera. Now, it's worth noting, I'm not just completely winging it here. I very much did calculate the required size for those vents based on the cross-sectional area of the cooling fan and accounting for the obstruction created by the grill itself, which will be printed with 30% grid infill. For the version of those parts going up on GitHub, I should have added all this and updated the drawings. Finally, I also need some holes for the rear I/O. I literally only just finished designing the breakout PCB for that, hence why they were not specified in the drawings and I'm doing them only now. And that should be the base almost ready for assembly. However, we still need some parts for the frame to actually line things up properly before we glue them together, so let's work on those next. Like I said in the last video, the frame is going to be made of some 30mm square steel tube. This is literally scrap metal. It used to be the legs of a pop-up gazebo, so it's a really rather low quality material and dimensionally not very accurate at all, which is certainly going to make my life a little bit more difficult. Additionally, it's also made of some quite flimsy sheet metal, which is only like 22 gauge in thickness. But apparently, because it's steel and not aluminum, it should still be rigid enough, people have told me. Thanks everyone for commenting on the video, by the way. Your guys' insights always help out a lot. Alternatively, you could of course use 30-30 aluminum extrusion. I really only use square hollow because I have the scrap and I like the way it looks. But since it is scrap, I do need to pick the nicest sections to cut my parts out of, avoiding all the holes. And unfortunately, I only have one shot at getting these parts right because I don't have enough of that material for a second set. So no pressure. A neat little trick to put a perpendicular line all around a piece of stock is to wrap a slip of paper around it and have the edge line up. Then you can trace it and be sure it's straight. And I'm using the hacksaw here to cut it, primarily so I don't burn the white coating with the angle grinder, but also because I'm less likely to slip and put a gouge in it than when I'm wielding a hefty power tool. With one end cut off, I can clean up the cut on the belt sander, occasionally checking with the square to make sure it's at a right angle. And there's really no reason I'm running this tiny 1 1/4 inch belt other than not having anything better at hand. Standing it up on the cut, let's see how bad it looks. Actually, quite reasonable. From this side, pretty good as well, so I think we're good to continue. And this is the same as before, just cutting it off with the hacksaw, which is something I can get away with because the absolute length of these pillars is not critical. So long as both are identical in length and not shorter than specified, it really doesn't matter if they are 1/2 millimeter or even a whole millimeter oversized. In fact, I'm cutting it 1 millimeter longer on purpose to leave myself plenty of material to sand down if necessary. And yes, those pieces look suspiciously short for a printer that size, but I double and triple checked the math in my CAD, and it does seem like the whole printer is just rather squat without the filament spool on top. Pretty much the only way to get these parts even close to the same length is to sand them simultaneously, even if it's harder to hit a satisfactory 90 degrees that way. Now lastly, I need a few mounting holes at the bottom of each of these, and even though it would be sufficient to just center punch and drill them the traditional way, I have a 3D printer, so I just went ahead and printed another drill guide. And this makes things really easy. Just push it on there, clamp it, and drill away to your heart's content. As previously mentioned though, these holes are slightly oversized for adjustability, so even if they don't end up exactly where they should, it's no biggie. And of course they have 2 sets of holes because they are practically instantly ruined with the heat from drilling, and I still need to do the other part. Now you can sort of see how it's supposed to go together, and we're finally ready for assembly. I would be lying through my teeth if I said I had a roadmap worked out for this part, so let's just do whatever seems to make the most sense, because there may not even be any good solution altogether, just varying degrees of bad ones. Either way though, the first step will be joining the pillars temporarily using the internal cross members, just so we can get everything lined up for gluing. And I specifically got screws with a rather large head to use here, just so I don't need washers. Importantly, the smooth side of both of these faces inward. Getting them the wrong way around would be pretty annoying, especially for these wiring holes which go to the bottom with a single one on the right. And to avoid this exact issue where I have to put nuts on screws and then somehow operate a wrench inside the tube, I 3D printed some nut holders which the nuts simply press into, and then I can shimmy the whole thing inside and it'll nicely hold the nuts for me while I tighten them from the outside. Now, before I tighten these down, I want to push the pillar as far inward and up as it'll go with the adjustability I have, just so it doesn't interfere with the bottom and side edge of the cross members. And I'm only doing this on one of them because the other one will first have to be adjusted. This is where things get really interesting, because not only do we want them to line up this way, but we also want the pillars to be at a perfect 90 degree to the table when both cross members are pressed down. Of course, it's theoretically the top edge we're really concerned about, but since these are, for our intents and purposes, exactly the same width, I think we can safely use the bottom edge as a datum instead, which makes things slightly easier. And this is definitely one of these situations where you want the flattest tabletop surface piece of scrap particle board you can find, as well as a square calibrated the way I mentioned earlier, because any inaccuracy here is going to make the next step much harder and ultimately, to a degree, impact the printer's accuracy. Okay, I think I got it as accurate as it'll be. That took about an hour of messing around, since the results I get from the square are different almost every single time. Definitely check from both sides alternately to cancel out any error, because error you will always get. For example, here I know this piece of countertop has a 0.2-ish millimeter bow in it over its length, so even a square will always show a gap at the bottom if I place it against something truly perpendicular. Now, with the screws on this second cross member also fully tightened down, we can set things up for gluing. I'm going to take one of the sides and use my calipers as a depth stop against the rear edge, then I can clamp it down. And this is the point where you want to double, triple, and quadruple check whether your pillars are still perfectly square, because every inaccuracy here will be immortalized in the printer's frame and have to be taken out via skew correction. Yep, that is 100% as stupid as it sounds, just because I heavily prioritized a simple and minimalist design over one that would be easy to make. If you're happy with it, you can go ahead and place the last clamp. If not, I'm afraid you'll have to go back and tweak the crossmember again to straighten things out. For the adhesive, I'm actually going to use super glue for two big reasons. Being very runny, it has an easier time penetrating into this very dense HDF, which should hopefully lead to a much stronger bond. And secondly, I can apply it from the outside as it'll wick into the glue joint all by itself, so I don't need to worry about hastily positioning and clamping slippery parts correctly before the pre-applied glue sets. And additionally, I can do sort of like tack welds in a few key places, holding the parts together until I can go in and fully glue it up. Now that I have the sides put on, it's time to add the rear panel, and since there's nothing special to worry about here alignment wise, I can just put it flush and fix it in place. It's coming together pretty fast now, isn't it? Next, I have the top panel to do, and this one is a bit more difficult again, since it determines the y-axis angle relative to the x-rail, which in turn depends on these pillars. Fortunately, the rear edge of this panel really turned out as perfectly square as I could have possibly hoped for, so I can easily just line it up parallel to the pillars using the calipers again, which should automatically put my rails at a pretty good 90 degrees since the mounting holes for those were centered on the panel pretty well. Of course, I also need to center it side to side, but that one's actually almost negligible because, as you can see, I deliberately made the part a millimeter wider on each side to leave myself some overhang that I can trim off using the palm router later. It really doesn't matter if the print bed is slightly off-center between the pillars, but it does very much matter if the rails don't run at a right angle. And I'm first tacking it down right by the pillars, of course, since the rest of the frame is still quite floppy. But once it's fixed in those spots, I can line up the back by making sure I get even stick out and tack it down there as well. Same goes for the front. I don't even have to make sure the sides are the exact same distance apart since I'm going to freestyle the fancy front bevel anyway, courtesy of it being a purely aesthetic feature. So all I'm really aiming for here is to not get the sides all wavy, since that would be visible and pretty ugly. Also, note that I'm doing all this with the base clamped down to my quote-unquote flat table because the top panel on its own is pretty bent, as are the sides, so it'll only hold a sort of flat shape after being glued together. Right, with it assembled, the obvious thing to do would be to double check whether the pillars are still square to the top panel, but since at this point, short of tearing it all down and starting from scratch, there is absolutely nothing I could do about it if they aren't. I won't check. I'd rather stick my head in the sand until I run into some serious trouble from the gantry not being properly rectangular, which I likely won't because I don't usually print stuff large enough for it to even matter if it's slightly out of square. I never even checked my other printers for that matter. So instead, I'm welding it out, so to speak, putting lots of glue to make absolutely sure it won't come apart again. And yes, super glue is definitely not the cheapest option here, but at this point, I really don't care about an added $1 or $2 in super glue if it means the printer won't shake itself to bits later on. A solution would of course be to assemble the whole thing using box joints, but again, that requires a functional laser cutter, which I don't have. Anyhow, it's now also safe enough to unscrew and take out the pillars for the first time so I can thoroughly glue in those cross members. I will say, this base is definitely something that would benefit greatly from being made out of sheet metal, and it's not that I don't have the capabilities to draw it up in CAD or anything. I could totally do that and have PCB manufactured for me, but I feel like that wouldn't quite fit the janky reuse theme of this project. Maybe for a future iteration of this printer I could do that. And now the difficult part is finally complete. We have a pretty solid wooden box with holes more or less in the right places. What I have left to do now is the fancy looking front bevel, as well as some internal bracing for rigidity, and of course a bottom panel to close it all up. Fortunately, from here on, everything else can be treated pretty much like any old woodworking project, since these things are mostly of aesthetical importance rather than a cornerstone of geometric accuracy for the whole printer. So because of that, and totally not because I'm very short on time to finish this video, please enjoy the following build montage. Alright, there we have it. It's finished. That was still a lot more work than I anticipated. In the end, it took quite a lot of super glue. I think I used up like 5 of these 2 RAM tubes. Then again, it's only like dollar store type grade stuff, nothing fancy at all. I also made a little mistake there. According to my design, the control panel should have been put on after the left and right fenders instead of first like I did. But in practice, this would be extremely inconvenient as you'd have them kind of floating on one side, which makes it a lot harder to get the angle right. Not to mention, cutting these bevels was hard enough as is. You probably saw I had to build a whole custom jig to do it since the bandsaw table only tilts the other way. So putting on the control panel last would just add a third difficult cut. The reason I designed it that way, with the control panel overlapping the fenders, is that with most types of wood, seams like this, even fully glued, sanded, and painted, will start to show again after a while, so you want to put them someplace they don't ruin the appearance if they do. In the end though, I'm happy with it. It did turn out nice enough overall, and pretty accurate too, I think, even though this should probably be considered quite an advanced project in terms of required woodworking skills. Not to toot my own horn here, but I am fortunate enough to have a reasonably well-equipped woodwork shop here, as well as about 10 years of experience to draw on. So for me, this is just a nice challenge, which does make me have trouble putting myself into the shoes of someone for whom this would be absolutely unfeasible, since I just take stuff for granted at this point. For this printer as an open source project, that's a bit of a bummer since it definitely limits accessibility, so the base would have to be redesigned to rely less on accurate fabrication, which probably means ditching the funny exoskeleton approach altogether and instead having the pillars connected by more metal tubing and adjustable in both directions, as well as replacing all the difficult to make sides and bevels with fully 3D printed skirts that somehow attach to the top panel. But anyway, I guess I'm rambling at this point. Don't forget that the updated CAD model and all the drawings for this first step in the build process are available on my GitHub, or actually printables too, for anyone interested in checking this project out. That being said, I hope you enjoyed. Sorry this video took so long. Not only was it a lot of work, I've also secretly been working on a massive upgrade for this channel, which I'll be sharing in the next episode. As always, huge thank you to everyone supporting on Patreon. The positive impact these fine folks had on this new 3D printer project is not to be underestimated. I'll see you soon. Sooner than last time, I promise. Bye bye.